Alrighty, friends. Topic 6 is tricky because since it's just like miscellaneous topics, doing one doesn't necessarily help you with the others because they could be a different miscellaneous topic. But I'll do 2024 even though it may or may not help you with the other ones. And we can certainly look at other ones if you need help. All right, consider the curve defined by x squared plus 3y plus 2y squared equals 48. So I'm looking at this and I'm seeing x's and y's mixed together. So I'm thinking I'll have to do some kind of implicit differentiation, but they were so nice. They went ahead and did that for me and generated the derivative of that. But that would have used implicit differentiation, which would be a thing you would need to know how to do. Question A, or part A, says there is a point on the curve near 2, 4 with an x coordinate of 3, doesn't give me the y coordinate. Use the line tangent to the curve at 2, 4 to approximate the y coordinate. So this is what we're trying to find. So keep in mind that in order to write the tangent line, you need to have the slope of the tangent at that spot, and the slope of the tangent at that spot is the derivative. So if we do our dy dx at that spot, using this as x and this as y, we'll have -2 and then plug in our x, 3 plus 4, and then plug in our y. And so when I do that, I get -4 over 19. That's a lovely number. So that's going to be the slope of my tangent line at that spot. So I can use that information, these guys over here and this, to write my equation of the tangent line at 2, 4. So y minus the y coordinate equals m times x minus the x coordinate, and the x coordinate they're giving me is a 3. So this will turn into 3 minus 2, which will turn into 1. So I end up with y minus 4 equals -4 over 19, which is totally annoying because I have to do that without a calculator, but oh well, it's calculus. So I'm going to end up with y equals -4 over 19, and I'm going to be adding over a 4. And I guess what I would do is just break down and be like, hey, 19 times 4 is going to be 76. So I'll get a common denominator and put this as 76, both over 19, and I'll land at 72/19, which is actually my answer. So whoopee-doo. And that is worth 2 points. It says 1 point for the slope of the tangent line, so getting to here, and then 1 point for my approximation. So obviously I need to show the work to support that, but those are where the actual points will come from. All right, let's take a little peek at B. B is the horizontal line at y equals 1, and they're asking, is it tangent to the curve? Okay, so for it to be tangent to the curve, if it's horizontal, then we would need that dh dt, oops, sorry, I was thinking about that last one I just made the video of, I apologize. I would have to have my dy dx equal 0 at that spot because I need the derivative to be 0 in order for me to have a horizontal tangent, and it's telling me that the line is horizontal. So, okay, so I'm going to bring down my derivative that they gave me right here, and I'm going to see, like, when will that be 0? And the only time a fraction can be 0 is if the top is 0. So the only time that would happen is if x was 0. Okay, so if x is 0 and it's going to be, the tangent line is at y equals 1, I would have to hit that tangent line. And so I would have to, I would have to hit that horizontal tangent line. So I need the y value to be 1. Otherwise, it's not going to hit the line y equals 1. So I'm going to go test this in the original equation that they gave me to see if it's actually a point on the line. So the 0 came from requiring my derivative to be 0. And since it's a fraction, the top would have to be 0 for the whole fraction to be 0. That's only true when x is 0. So that's where this came from. Then I have to, like, use my noodle to go, wait, if I'm going to be tangent to the curve y equals 1, or tangent to the line y equals 1, I have to actually touch the line y equals 1, which means my y has to be 1. So I'm going to go back to that initial actual graph and put in Everywhere there's an x, a 0. And everywhere there's a y, I'm going to put in a 1. And see if it equals 48, which it doesn't. And so in order for us to have a horizontal tangent at 1, we would need the point to be 0, 1, and that point's not on the line. So since 0, 1 is not on the curve, then y equals 1 cannot be a horizontal tangent. Because by definition, a horizontal tangent is going to have a slope of 0, but it's also going to hit a point on the curve. And it hits the point 0, 1, which we've proven is not on the curve. So the points for that part B, it says considers dy dx equals 0. So this is getting us a point. And then answer with reason is kind of what we did down here. So that kind of earns us those 2 points. Okay. Part C. Let's give that a whirl. In part C, it says the curve intersects the positive axis at root 48, because why not, 0. Is the line tangent to the curve at this point vertical? Think about what that means. If you have a vertical tangent, that means your slope or your tangent value, dy dx, would have to be undefined. So what they're really asking you is this dy dx undefined at root 48, 0? So I'm going to find my dy dx equation from up above, and I'm going to put in what I have for an x. So I have negative 2x from up in this business right here. And where the x was, I'm going to put my root 48, which is an unpleasant number, but it doesn't really matter. On the bottom, I'm going to have 3 plus 4y, and my y is 0. So I end up with negative 2 over root 48 all over 3, because that's literally nothing. This is not undefined because the bottom's not 0. So it's not undefined because the bottom is not equal to 0. And if it's not undefined, then therefore there is no vertical tangent at that point. Sorry, that should be root 48, 0. So vertical tangent, when they say that, you have to be like, oh, that means the derivative is undefined. And here's the derivative. And when I put those numbers in, it's not undefined. So since it's not undefined, I don't have a vertical tangent. And sadly, this one's only worth 1 point. It says you have to have your answer with your reasoning. So basically everything I have is going to earn me that 1 point, which feels like a ripoff. Now the last one, part D, is worth 4 points. So let's see how many of those we can get. For time greater than or equal to 0, a particle is moving along another curve, obviously. Particles are just moving everywhere, which is that. Okay, so the other curve is defined by that equation. At the instant the particle is at 4, 2, so my x will be 4 and my y will be 2. The y coordinate of the particle's position is decreasing at a rate of 2. If you have a y changing at a certain rate, they're telling you dy dt. Because it's decreasing, I'm going to make it negative and then 2. So that's going to be an important piece of information. At that instant, what is the rate of change of the x coordinate? So they're asking me for dx dt. That's the thing I don't know. So I have to find the derivative, which is going to use implicit differentiation. So let's do that. Here I would have 3y squared, and since that is a y term, and I'm doing this all in terms of t, I would have dy dt. This is actually a product, my friends. So I'm going to have to do 2 times x, and then I would multiply by the derivative of y, but that's only 1. But because I took the derivative of y, I'll end up with a dy dt. Then I'm going to have to add the second part, which is y, times the derivative of the first part, which would be just 2. But because we're doing in terms of t, that would be dx dt. And then the derivative of 24 is L zippo. So now what I'm going to do is plug in what they told me. They told me my y value is 2 right here. They told me dy dt was -2 right here. Then I'm on 2. Now they told me x was 4. And again, dy dt is -2. Here I have y, which is 4 times, that's a lie, y is 2, brain fart, sorry, y is 2. And then I have another 2 from doing my derivative, so that's this guy. And then what I don't know is dx dt, that's the thing I'm trying to find. So these numbers are all gonna go together and add up. And so in the end, this part is -24 and this part's -16. So they total -40. So I end up with this being 4 dx dt, and then I add that 40 to the other side. And now I'm trying to solve for dx dt. That's the thing they want to know. So I would simply divide out that 4, and then it's telling me that the x is changing at a rate of 10. And so this one is worth 4 points. And I would go back and look at the rubric. It says attempts implicit differentiation. So even if you just give this the old college try before you get to college, that's going to get you a point. If you have it correct and set equal to 0, that's going to give you a point. If you use that dy dt is your -2, that's going to be a point. So if you're plugging that in here and here, and then getting your answer. So this 4th point comes kind of from that work, and then doing it correctly and ending up with the 10 is that last point. So hopefully that helps you a little bit on that. And again, it's just tricky in the topic 6 because this next one's a table, which is not really what I just did. And if I have time, I'll make another video of that because those table ones are pretty popular. And so I would like to at least go through one of those. This one, again, looks like implicit differentiation is used. So obviously that's a topic that we're going to want to have to look at. Here, average rate of change. Think about that. Average rate of change is just using slope. Equation for the line. Oh, sorry, you guys. Oh my gosh. I'm looking at the questions on my computer and scrolling through them and talking, but you have nothing to look at. I'm just going to stop talking now. Bye, guys.